This is a video about multiple regression, when you have more than one independent variable predicting your dependent variable. Predictor variables are said to influence the criterion variable. Another way to describe your regression test is to use the verb form. We regressed fear of public speaking on age, gender, and experience giving a speech. Or Facebook satisfaction was regressed on age, number of friends, and gregariousness. Regression works best when the predictors are interval ratio level, although some variables like gender or belief in God are dichotomous, coded 0 and 1, and called dummy variables. Random assignment to a control or treatment group in an experiment is a dummy variable. Bear in mind that the criterion or dependent variable should always be continuous unless you use something like logistical regression, which is beyond the scope of this course. The key output of a regression test is the beta weight, which is like the correlation coefficient ranging from 0 to 1. These are standardized to ignore the influence of unknown variation captured in the y-intercept. Only use the unstandardized regression weights if you're predicting an outcome like money or grades. Standardized beta weights are perfect for testing communication theory. The bigger the beta weight, assuming it's statistically significant, the better. Multiple R squared is like R squared in a linear regression of two variables at a time. That is, a Pearson R correlation. It reports the total explanation provided by the predictors with significant beta weights. Instead of a best fit line in two-dimensional space, multiple regression of more than two predictor variables calculates a best fit located in hyperspace, a mathematical cloud, something that cannot be drawn or seen, let alone imagined, but still numerically is real. The ability to parcel out the relative influence of many variables upon your dependent variable of interest is why researchers favor regression as a very strong evidentiary tool. Multicollinearity can be a huge problem for regression. If variables are too similar, when they get subtracted from each other in the underlying math, there's a risk of division by zero, which is undefined and produces untrustworthy beta weights. Always check the SPSS box for collinearity statistics, which are reported with two measures that are reciprocal. Because VIF and tolerance are two sides of the same coin, just use tolerance, which ranges from 0 to 1. The farther away from 0, the better. And it's easy to remember because the name suggests that the predictor variables tolerate one another better. You have a wide choice of methods of what order the predictor variables are entered into the final equation. Stepwise looks for the best solution. Hierarchical uses blocks based on levels of explanation, where demographics are usually entered first, then simple attitudes and behaviors, and then finally the variables about which you hope to make your strongest claims. Additive effects are measured with increment to R squared, which you can request from SPSS. If the increments are statistically significant, you can make strong claims, although their practical significance might be small. Moderator effects are interaction effects added into the list of variables. Without them, the regression model was called a main effect model. Let's examine some data from a study I did many years ago looking at satisfaction of TV viewers. I knew I had to include age and gender as baseline demographic predictors. I also knew that number of channels usually watched, called repertoire, and typical time spent viewing might also predict satisfaction, but I really wanted to see if the motivations for viewing affected satisfaction. Here's the data. I used a popular scale for satisfaction that tested high for reliability. I chose a hierarchical regression to enter my motivations last, but let's allow SPSS to figure out the most important predictors on its own. So let's go to the data view so we can see our columns of data, but most importantly we go to the Analyze box, then Regression, then Linear. In this example, I'm going to take all 6 variables and enter them into the independent variable box. First, our dependent variable is satisfaction, And our independent variables are channel repertoire, age, and these are in no particular order, sex, time spent, and our motivations, instrumental motivations, and ritual motivations. And we're going to choose the stepwise method. Under statistics, I'm going to ask for R squared. We'll do collinearity diagnostics later. When I click on OK, here is the regression output. You may be able to see, let me scroll down. SPSS needed 3 tries to find the optimal solution with 3 models. The first had a beta weight of 59 with instrumental motives, tossing out repertoire, ritual motives, and age. Gender and time spent were borderline significant. The second model brought in time, boosting total beta to 0.68. The third model added gender, dummy coded with a higher value for female, to get the 3 predictors now to 0.70. But total beta is not the same as total R, which is your total correlation. And in this case, it was 0.61 with the third model, which is equivalent to 38% explained. Conceptually, I chose to use hierarchical. So let's go back to Analyze, Regression, and Linear, and hit the Reset button. Our dependent variable is still satisfaction. But we're going to put in age and gender in the first block and click Next to get to the second block. Then we're going to put in time and channel repertoire, and that'll be our second block. Finally, we'll put in our motivations, instrumental and ritual. And under statistics, I'm finally going to ask for not just R squared change, but also collinearity diagnostics. Click on Continue and OK. I believe that it's easier to explain that demographics contributed 5% in the R squared change column. At this point, both age and sex were significant. The next block, time and repertoire, added 7% to get us to 12% explained. The final leap was from the motivations that added 27% to get us to 39% explained. Only slightly better than the stepwise method, but easier to understand using theory-based blocks rather than optimization schemes in SPSS. Note that instrumental motives had the largest beta weight. If we look at the collinearity statistics, the tolerance column shows large coefficients close to 1, removing any worry of multicollinearity. That's a lot for one video. See you next time.